Okay, this is a Dalton's law of partial pressures problem. So this question is about the helium and oxygen that's mixed in dive tanks to prevent the bends. So we have two gases here that are going to be mixed together, helium and oxygen. So I'm going to make a chart for each gas. So we'll do helium in red. So the helium gas, we know a couple of things. We know that the volume of the helium gas is 46 liters. We know that it's at a temperature of 25 degrees Celsius. Remember, we're going to do 25 plus 273. So really we have a temperature of 298 Kelvin. The pressure of the helium is 1 atmosphere. And that's all we know about the helium. So now we're on to the oxygen. We'll do that in blue. So the oxygen tank is 12 liters. The temperature is the same, 25 degrees Celsius, so 298 Kelvin. And the pressure is 1 atmosphere. So both of these gases then are going to be mixed together. They're going to come together, and they're going to be placed into a tank that has a volume of 5 liters at a temperature of 298 Kelvin again, 25 degrees Celsius. And the question is, what is the pressure now inside this tank? So in order to do that, we need to find the moles inside the tank at the end. So we need to figure out how many moles of helium do we have? And then how many moles of oxygen do we have? And we're going to do both of these the exact same way, and that's by using the ideal gas law. So we know PV equals nRT, and we have enough information to find the moles. We know the pressure, we know the volume, we know R, the gas constant, and we know T. So for the helium, 1 atmosphere times 46 liters equals N times R, 0.08206. Yep, I'm going to run out of room, times 298. So the moles of that is 1.9 moles of helium. We're going to do the exact same thing for the oxygen. So pressure of 1 atmosphere again, new volume of 12 liters, N 0.08206, and still a temperature of 298 Kelvin. And this N is going to be smaller. We have a smaller volume, so this N should be smaller, this number of moles. And for oxygen, I got 0.49 moles of oxygen. So now we know, sorry, my T is messed up now, but now we know N. And N is 1.9 plus 0.49. So we have both gases now in the same tank. So one more PV equals nRT. P times V, our volume is 5 liters now. N is 1.9 plus 0.49. So that's 2.39 times 0.08206 and times our 298 Kelvin. And you get the pressure in the tank at the end is 11.7 ATM.